విమ్ము తోటి అడుగు పోతుంది. విమ్ము తోటి అడుగు పోతుంది.
Good afternoon, everyone. Today's topic is cluster analysis and what kind of data we are using in cluster analysis. In that, we are going to see the K-means algorithm. First, what is cluster analysis? Cluster is collection of data objects. That means a similar kind of data are grouping in one cluster and other dissimilar type of data is grouping in another cluster. First, let us see why we use cluster. Like when we are having a huge amount of data, if we want some similar kind of data, then we use the cluster analysis technique. Example, like if they have given a basket full of fruits, there we are going to separate the data based on the shape, color, and anything. Example, like we are going to separate the apples based on the red color and round in shape, and banana oval color, that yellow color shape. Based on the color feature, we are going to separate some things. Based on the feature, size, and everything, we are going to separate the things. Here, cluster analysis is a major step in the result, like in the research process. Here, cluster analysis mainly used for finding similarities between the data objects and grouping the similar data objects into the cluster. Here, in the cluster analysis, we are having, it is an example of unsupervised learning. That means there is no supervisor to train the machine for this cluster analysis. So we have to learn from the observation rather than examples. Here we are going to see one example here. Clustering. In this clustering, here first cluster, intra-class distance are minimized. That means in the same cluster, the distance will be minimized. That means in the cluster, what are the objects present in that, the distance will be low. In the other two clusters, that is inter-cluster distance are maximum. That means here we are grouping into two clusters so that the distance will be more. Next, qualities of good clustering. So we can say that good clustering is mainly depends upon high intra-class similarity and low inter-class similarity.
5.1, 5.2 examples.
In the same cluster, the distance will be always minimized. And different clusters, the distance will be more. So it depends upon the similarity measure and the similarity measure. Similarity is nothing but similar objects, and the dissimilarity are the nothing but the different kind of objects are present in the different cluster. So it is measured to discover the like hide some patterns, or we can able to discover the new things which are not visible to us. So the measures we are taking in the similarity metric and dissimilarity metrics. Here, similarity is expressed in terms of distance. Here, when we are taking in the clustering example, the distance between the two data objects is very low in the intra-class similarity one, whereas in the inter-class distance are maximized. So here the intra-class similarity or distance are low, so we are going to consider that type of clusters are the good clusters. Next one, yeah, we can define the distance functions by using the different data types. Like we can go for interval scale, boolean one, categorical one, ordinal, rational, and vector variables. So again, we should also assign weight to the different weight, like different variable based upon the applications and the meanings given to that. Next, more properties of the clustering algorithm. So here in the clustering algorithm, not the single kind of data type we are considering. We are considering the different kind of data types, and it also able to deal with the noise, and we can also remove the outliers. Outliers are nothing but the objects outside the cluster are called as outliers, and the noise is nothing but the objects which are not like undisturbed data or the not related data are removed from this. And it is not defined to a small dimensions. We can consider the many number of dimensions, like high dimensionality is like measured by using this clustering algorithm. Here it can also handle the dynamic data. Where are we? This clustering analysis is used in many applications. Let's see an examples for this. Let's take a marketing. Yeah, in the marketing, here we are having different kind of people, right? Like a marketing person want like high income the people, or the low income the people, or the middle income the people. Here, after like by clustering, we can able to discover the different groups of people, different income people. We can going to target our ideas, or we can going to directly contact the high income people, or the low income people, or the middle income. Based on the income, the marketing people will call to the person directly, and he can directly advertise for his products. Like example, if it is for a low income people, he can't give for like example like more than his income, he can't spend a loan. So based on that, we can do the marketing. It helps in clustering. So next, land use. So here we can identify the area of similar land in the earth observation by using this cluster analysis, and it can also be used in the insurance or the city planning, like identifying the group of houses which are according to the similar type, value, and the geographical location. These are the kind of applications we can use. We can also use in image processing to like identify the similar kind of images, similar kind of things based on the cluster analysis. Here next, what kind of data we are normally using in cluster analysis? When we are considering the main memory based clustering, we use two types of matrices. One is data matrix, other one is dissimilarity matrix. Here in this data matrix, here he has given one matrix, right? Here x1 to till x1p. That means it is order of n objects and p variables. Here, like he can have the many number of attributes, not the single attribute here. Here he can consider age, height, weight, gender, and so on. All the different types of attributes will be considering in the data matrix. Next, in the dissimilarity matrix. Here in the dissimilarity matrix, it stores the same kind of objects by like varying the order or the priority. Here 0, P of 2, 1, P of 3, 1, like until P of 2. That means these kind of entities are stored in the rows and columns here. Whereas the data matrix, we are storing all the different kind of attributes like age, height, weight, gender, and so on. So whenever they have given the like clustering technique, in order to perform the clustering, when they have given the data in the data matrix, first we need to convert the data into the dissimilarity matrix and go for the cluster analysis. Like that, we will continue in the cluster analysis technique. Next one, type of data in your cluster analysis. Interval scaled variables. This is the kind of data in your cluster analysis. That means they will give a range of values. We need to measure that particular range in terms of dissimilarity of objects. That means we are going to group the distance based upon the calculator. Here we have given example like x1, y1, x2, y2. So based on the distance of objects we are getting, we are going to group that object to be a cluster 1 or cluster 2 or the cluster 3 based on the distance. For that, the measures we are calculating here is Euclidean distance, Manhattan certain distance and this would be distance. Let's see an examples of this. This examples is there in your question bank, critical thinking. So here ma, first we need to calculate the standardized data. For that we are using the absolute deviation. So for that ma, what is the formula? 1 by n into x1 of one particular data object minus mean till the last object minus mean. Next, in this interval scaled variables, we are having another one to calculate the z-score normalization. So the formula for the z-score normalization is x minus mu by standard deviation. X is nothing but the variables which they have given in your question. Based on that question, you are going to solve those z-score normalization. So by using this mean absolute deviation, it can detect the outliers and it can disappear completely. So here we are having one example, ma. So what the question he has given the following measurements for the variable e, and we have given the variables 18, 22, 25, 42, 28, 43, 33, 35, 56 until 28. So he has given the question standardize the variable by the following. First, compute the mean absolute deviation of x. Second, he has mentioned to compute the z-score normalization only for the first four measurements. The x values are nothing but in the second question, x values are 18, 22, 25 and 40. All the first mean absolute deviation. What is the mean absolute deviation formula? Directly he has given, right, 1 by n, x1 is first variable minus mu plus mod of x2 minus x3 minus min till the last variable. So what's the formula? Total number of variables are nothing but 1 by 10. Variable what we are considering here is 18. So 18 minus the mean formula. What is the formula? x12 is by total number of variables. Total number of variables by 10. 1 by 10 into first variable 18 minus 32 plus mod of 22 minus 33 plus mod of 25 minus 33 is the last variable. So now we have to do the subtraction. After that we do the formula. We are going to get the answer. That is 88 by 10. So 8.8 is your answer. I hope all of you have understood the mean absolute deviation. Next, I'll go for the z-score normalization. So here we have given the mean and the standard deviation. What is the mean? He has given 33 and the standard deviation is 0.8. The first variable x. So what is the formula for the z-score? X mu by standard deviation. For the first variable 18, right? 18 minus what is the mean value? 33. For standard deviation is 8.8. After calculation, we are going to get the value expression is 1.2. Same way, we have to calculate for the 22, 25 and the 42. Different variable values of z-score normalization. In order to calculate the similarity and the dissimilarity delay, there are other methods also. They are nothing but probability distribution and certain distance. So this is a normal formula. So some popular distances like Milwaukee is used. So here LP normal data formula. First, when we have given equal to 1, when we are considering the p equal to 1, that is in the form of L1 norm. Directly minus x2 minus x1. Last value solve the question. Next is distance. That is nothing but square root of all all the values. This is your Manhattan distance. For the Manhattan distance, we need to take the value of P equal to 1, and for the Euclidean distance, we have to take the value of Next, let's solve the problem on Euclidean distance, Manhattan distance, and Milwaukee distance. What they have given the two objects, namely two objects are 22, 1, 42, 10, and 0, 36, 8. In order to calculate the Euclidean distance, we are having the formula square root of, is the first object we are having 22, right? 22, this will take it as x1, y1, z1, like q1, something. Second, 20, 0, 36, 8. So here, in order to find the Euclidean distance, first value, first attribute minus first value of second attribute. 22 minus 20 whole square. Second value of the first tuple, 1 minus second tuple value of second value, 1 minus 0 whole square plus 42 minus third value of the second value. So 42 minus 36 whole square plus 10 minus 8 whole square. After calculating that, we have to find the square root of that value. Here the distance is 0.708. Once again, I am explaining that. So what is the first value in the first tuple? 22. What is the second first tuple value in the second tuple? 20. So 22 minus 20 1 minus 0 whole square, 42 minus 36 whole square plus 1 minus 8 whole square. So we are going to get the value of 0.08. Second distance, nothing but of the same value, but we are not going to consider the square. So 22 minus 10, 1 minus 0, modulo of 42 minus 36 plus minus 8. After that, we need to calculate. That means we have to do the sum function. Yeah, we got the value 11. While calculating, we can consider any distance measure. Here we can also, like when we are calculating, like next coming Euclidean distance, like in the K-means algorithm, you can also use the Euclidean distance, Manhattan distance. Next, mark. Next is Milwaukee distance. Here in the Milwaukee distance, he has given 2 equal to 3. So here, fifth root of the value. Root of the value, and the value here we should take modulo of 3. 22 minus 20 plus 1 minus 0 whole cube plus 42 minus 36 cube plus 10 minus 8 whole cube. After that, we are getting a value of 30 whole cube root. Fine, we are going to get the value. These are examples from our question bank. He has given us 5-dimensional numerical sample of A. So here same samples, A sample, B sample he has given, and he asked us to find out the so 5 samples. So the value minus 1 whole square plus 1 minus 0 whole square plus 0 minus 2 whole square, 3 minus 5 whole square plus minus 1 minus 3 whole square. The value we are getting is 5.099. These are the intervals scaled values for the first data. We are going to calculate all the interval scaled variables. Next one, another type of data variable is binary variable. As we know, binary variables has 2 values, either 0 or 1. So 0 is for negative value and the 1 is for positive value. This small table, when we are taking for the values for any two objects or for the same object, 1 1 0 and 1 0. It is 1 1. We are taking first. It is like 0 1 S 0 0 R and 0 0 T. Like that, we are going to calculate the binary variables. Next, in order to calculate the distance measure of binary variable for both the symmetric and asymmetric, as given the formula here. Binary variables for the symmetric is R plus S by 2 plus R plus S plus 2. This is for your symmetry binary variables. Already we have discussed that in your table. Next, in the asymmetric binary dissimilarity. In the asymmetric binary dissimilarity, we are not going to consider the negative value. That means here in the table, 0 and 0. That means here the negative value, here the negative value. We are not going to consider that equality. This is for your binary dissimilarity. Again, in the binary asymmetric binary similarity function, they have given the formula Q by P plus Q plus R plus S. This is called as Jaccard coefficient. This is for your binary variables. These are the some distance formula they have been given in order to solve the distance function. Next type of data is nominal data or the categorical data. Nominal data or category, that means it has more than 2 states, whereas the binary have 0 and 1. So example of this nominal or the category data here, let's take an income, like age of person is divided into 3 groups, right? Like low age people, middle age and old age. So here we are having the outcome of people as more than 3. That means young age people, like young age people, middle age people and the old age people. So the categories or the values are more than 2. So there comes under this nominal or the category values, category variables. Now here, in order to calculate the same distance formula for this nominal or the category variables, we are having the formula P minus M by P. So M is nothing but total number of matches and P is total number of variables which they have given. And when we use a large number of binary, we have to create a new binary for each value of this matches and we have to calculate that nominal state. Next is your ordinal variables. Ordinal variables is nothing but it can be either discrete values or the continuous values. So when we are considering these ordinal variables, the order of the matrix is important. Like example, ranking should be considered. That means we should give the importance to ranking. Like we have seen clustering and the types of data in the clustering. Next one, it is like clustering algorithms are categorized into different types. The first method in this is partitioning method. As the name suggests, partitioning method. So we are going to divide this complete data set or the database into a partition, small parts. We are going to form the cluster. So here we are given a complete database of n objects. Here in the partitioning method, we are going to consider the the total n objects. We are forming the clusters. But whenever we are forming the cluster, the value of the partition should be less than n. Should not be more than n. A data object should not be more than a database. If it is more than a database, it is completely wrong. So we should always consider the cluster k than or equal to n objects. Partitioning method, we can form a group like a cluster. Compulsory there should be a data object in cluster. If there is no data object in cluster, we should not consider that. And each object must belong to exactly only one group. That means same object, like A object should not belong to cluster only one group, and in the clusters when we are forming that in the cluster the data should be compulsory available, and the data should be like it should be belong to only one group. The similar kind of data should not be available in other clusters. Now in this partitioning method, let us see the method in this partitioning method is k-mean method. So let us see the k-mean clustering algorithm. Here, k-mean clustering method. So k-mean clustering algorithm is unsupervised. What is unsupervised? So first, let's see what is unsupervised. So in the unsupervised technique, there will be no like supervisor. No one will be trained for the method. So we should form that. We should assume something and we should move on. That means we should learn by the observation. So k-mean is an unsupervised technique. Here in the k-means algorithm, we are partitioning the given data into some different clusters. And here cluster is nothing but a similar kind of data point with certain similarity. Here we have taken an example, right? This is some kind of before k-means algorithm and after k-means. What is the difference here? In the first set, we are given the complete data points with some color. After k-means algorithm, we are grouping them based on the color here. In the first, blue color is one group, red is one group, some kind of orange or yellow is formed into others. So here we are having a 3 clusters based on the color.
Hi there. I invite you to apply for the pre-diploma program in data science by applying Bangalore
Here 3
into
clusters based on the color.
point on
Here in the k-means algorithm, when we are considering, they have given the different kind of data points, right? The first data points, we should choose that element or the data point into a cluster with the nearest mean. Data belonging to the cluster should have a high similarity. That means like similar kind of features data points and data belonging to the different clusters should have a high degree of dissimilarity. So here we are considering the similarity and dissimilarity. Similarity means we have seen, right, Manhattan distance, Milwaukee distance, and Euclidean distance. For this k-mean clustering algorithm, we need to follow some kind of steps. Let us see that here. First, k-means clustering algorithm. First, like they have given the n database, right? N data set. In that data set, we have to choose the number of clusters first. So I have they have given a complete data set. In that, I am choosing a 3 clusters. That means the number of clusters is 3. 3. And firstly, I am choosing that. First is that point how to keep in mind. Step 2. Now we have formed the 3 clusters, right? Assumed. Step 2. We have to select. First, they won't give the cluster centroids or the means. First, we have to select the cluster centers. Whatever the data point, it is not the actual correct center point, but we are going to select that particular point as some data point center, and we are going to select. First, we'll select 3 clusters, right? I'm taking the 3 clusters, so I'm selecting 3 clusters as some data points like A. I'll explain with example also. First, we need to randomly select some data points. After selecting that particular center, then we have to find the distance, Euclidean distance. We can use any Euclidean distance or Manhattan distance or Milwaukee distance. Next, step 3. In the step 3, we have to calculate the distance between that each data point and the cluster center. What is the formula for that? When when we are taking the Euclidean distance, x1 minus what is the clustered data point. If I have taken the 2, 4 as a data point and 5, 6 is a clustered point, so 2 minus 5 whole square minus 6 whole square, that is like observed value minus centroid cluster value. Second point of that observed value minus clustered center. To take that, and we have to calculate the, after calculating the data point, every data point, each and every data point, we have to calculate the Euclidean distance. After data is calculated by using this Euclidean distance, whose distance is less to the cluster, we have to choose the three clusters, right? After choosing, like we have to calculate from the data point 1 to the center cluster 1, and the same data point to the cluster 2, and the same data point to the cluster 3. After calculating that, we are getting a value that we have to move that to assigning each data point to some cluster. A data point is assigned to that cluster whose center is nearest to that. That means after calculating all the data points, the data points should be moved to some cluster, right? But for that we need to use the Euclidean distance. Here in the whose Euclidean distance is less, that data point will be moved to that particular cluster. Next, after calculating that point, again we have to recompute the step. First step is completed, right? For the data point, we have moved all the data to some different clusters. Again, in the second iteration, what we have to do is we form one center, right? Again, for the we are going to get some different values in the cluster. Now, after getting those values, again we have to find the newly data point. Again, we have to do the same process till the center of cluster is computed by taking the mean of all the data points contained in that cluster.
Yes, students.
Repeating the procedure from 3 to 5 until any of the following stop criteria is met. Now let us see one example.
Neeta.
Ma'am.
చేయమ్మా అందరు నేను
Ma'am.
పార్టిసిపెంట్స్ ని మేనేజ్ పార్టిసిపెంట్స్ కి వెళ్ళి అన్మ్యూట్ చెయ్యి అందరినీ మ్యూట్ ఆల్
My friends and my
Let's all sing again.
నెల పైన హాఫ్ వస్తుంది 2 నెలలకి ఒక సోప్ వస్తుంది
Let us solve one example by using this K-means. For that, the initial clusters I am taking here is A1, A4 and A7. So I am here using this Manhattan distance for calculating this K-means algorithm. What is the question he has given? We can use the distance function and K-means algorithm to find the 3 clusters after the second iteration. So here we have to go for the 2 iterations.
Some makeup, expensive equipment.
So for the iteration 1, we have to calculate the distance from each point to the center of clusters. So what I have taken A1 as your center, so 2, 10 as first center, and other 3 centers have 3. So for that, I am calculating the Manhattan distance. So 2, 10 is your first point, and your cluster 1, 2, 10. For that, we are using a formula Manhattan distance mod of x2 minus x1 plus. So 2 minus 2, 10 minus 10. So the value for the first cluster is 0. Next, we have to choose for the second cluster A1, 10 for the second cluster. So C2 is the other cluster. The value for the C2 is 5, 8.
थोड़े
So
slow बोलो।
here, same thing. Again, for the second cluster, for the same data point, we have to calculate the Manhattan distance. After calculating, that is, what is the center? Centroid here, 5 minus 2 plus mod of 8 minus 10. Here, we are getting a value 5. Calculating distance between A1, 2, 10 to the cluster 3. So again, the same data point, we need to calculate the distance for the cluster 3, 1, 2. So after calculating, we are getting a value 9. So for the same data point, for the 3 clusters, we are getting 3 different values. In a similar manner, we have to calculate for the each data point to the all the clusters. So here I have drawn a table here for the A1 data point 2, 10, right? For that cluster 1, and for that distance 5, 8 to the cluster 2, and next cluster like 2, 10 to the center 1, 2. For that we have like it might like all the 8 points we have calculated all the distance. Now we have to choose whether A1 is belong to C1 or C2 or C3. For that we need to check the distance. Here A1 we got the value 0. Here whose distance is low? A1 distance is low. So A1 is distance is low at cluster 1. So we have to move the A1 to the cluster 1. Next A2. At the A2 we are having the points 2, 5, right? In the 2, 5 when we are calculating the Manhattan distance, we got the 3 different values 5, 6, 4. So in this row we are having the lowest value is 4. So A2 point is moved to the cluster 3. For the A3, we are having the 7 as low value. So that 7 will be moved to the cluster 2. Next A4 point. For the A4, at the A4 point, we are having the 0 at cluster 2. So that will be moved to the C2. Next A5 point. At the A5 point, it is at cluster 2, it is lowest. So it is moved to C2. Same way A6 is at like it is at C2 lowest value. So A6 is moved to the C2. Next A7 point, it is lowest at cluster 3. So it is moved to the cluster 3. And A8 point, it is lowest at cluster 2. That value is moved to the cluster 2. This is how we have formed the new clusters now. So cluster 1, we are having only 1 point, 2, 10. Then at cluster 2, we are having the A3, A4, A5, A6, A8. And the cluster 3 point, we are having. So third cluster contains A2 and A7. So these are your 3 different clusters. Again, what we have to do again, we have to recompute the new clusters. That means new cluster center is computed by taking the mean of all points contained in that cluster. So for the cluster 1, we have only 1 point, right? The center of the cluster for the cluster 1 is same. So we need not change the for the cluster 1. Next, for the cluster 2. So here for center of the cluster, so here we have to check the points of C2. So what are the center? We are having 1, 2, 3, 5 points they have given. So for that 5 points, we have to calculate the mean. Then that will be your new center of your cluster. So what is the formula? 8 plus 5 plus 7 plus 6 plus 4 by total values is by 5. So total number of values are 5. So by 5. Then by point by 5. So 4 plus 8 plus 5 plus 4 plus 9 by 5. So the center for the cluster 2 is 6, 6. Next for the cluster 3. So again for the cluster 3, we are having the 2 different points, right? So for that again we have to calculate the mean. So for after calculating the mean, we got the cluster value as 1.5 and 3.5. This is for your iteration 1. But in the question, he has asked us to calculate for the iteration 2. So again, we have to compute the values, right? So for that, we have to calculate the distance of each point from the center of the 3 clusters. Again, the distance is calculated by using Manhattan distance formula. So for that, again, for the A1 2, 10, say center is 2, 10 as usual, because there is no change for the cluster 1 group. But the center of the cluster C2 has become 6, 6 because there are 5 variables. That means 5 data points are added to the cluster C2. Again, calculating the distance A1 2, 10. Again for the cluster 2, again same thing, we have to calculate it for the cluster 3 also. In the similar way, we have to calculate for all the different points. After calculating that, we got the different values here. So for A1 2, 10 from the distance 2, 2. Again from the 6.6 and the distance from 1.5 to 3.4. After calculating all the values, same procedure. That means whose distance is low, that will be moved into the same cluster. That means same clusters. So here in this 2, 10, the distance is 0. So that point is moved to the cluster 1 itself. Next, in the A2 point, we are having distance is low at the cluster 3 point. So that is moved to the cluster 3 point. Same way at A3 point, the cluster value is low at 4. So it is moved to the C2. Next, at the A4 point, it is low at cluster 2. It is moved to C2. At the A5 position, it is moved. It is low at 2 point, cluster 2. So it is moved to cluster 2. At A6 point, it is low at cluster 2. Again, it is moved to C2 itself. A7, it is moved to the C3. Next, A8 point, it is moved to the C1. So now another value is added to the cluster 1. So now the new clusters becomes, for the first cluster contains A1 2, 10 and A8.4, 9 is also moved to the cluster 1. So now the cluster mean value will be changed here. Now cluster 2 is contain A3, A4, A5, A6 and cluster 3 values are the cluster 3 contains only 2 data points. Now we have to recompute the new clusters. So for that, center of clusters, right, mean. So 2 plus 4 by 2, 10 plus 9 by 2, we are going to get the new cluster mean as 3, 9.5. And for the cluster 2, again we have to calculate the mean for the all the data points. For the cluster 3, again we have to calculate the center of cluster. So after calculating, we got the first cluster as 3, 9.5 and second cluster as 6.5 and 5.25 and third cluster value as 1.5 and 3.5. So we have completed the iteration 2 also. Now the centers are 3, 9.5, 6.5, 5.5 and this is your iteration 2 examples. So in the question itself, sometimes they will give us the clusters and the data points and they'll ask us to calculate for the first iteration. In the some questions, they'll ask us to calculate for the second iterations, ma. Thank you, ma. Shekhar.
No, అయిపోయిందా
Ma'am, sir, close, sir.
క్లోజ్డా
Close, sir. Session closed.